Next question, find the Fourier sine and cosine transform of function x raised to power m minus 1. We know that Fourier cosine transform of fx is integral 0 to infinity fx cos sx into dx, and Fourier sine transform can be written as fs of fx integral 0 to infinity fx sine sx into dx. Here f of x is given x raised to power m minus 1. Now Fourier cosine can be written as integral 0 to infinity, substituting the value of fx x raised to power m minus 1 cos sx into dx. Assume that equation first, fs of fx is integral 0 to infinity x raised to power m minus 1 sine sx into dx, equation number second. Now we are using gamma function, so gamma of m, here we are using gamma function, definition of gamma function. We are using definition of gamma function, and gamma function can be written as gamma of m is integral 0 to infinity x raised to power m minus 1 e raised to power minus x into dx. Now putting x to iota sy so that dx, derivative of x is ds and derivative of y is dy. Now changing the function from left side, gamma of m is, and right side, when x is 0 y is also 0, when x is infinity y is also infinity, then there is no change in the limit. Then limit integral 0 to infinity x raised to power x की जगह हम रखेंगे आयटा एस वाई एंड ई रेज टू पावर माइनस एक्स ई रेज टू पावर माइनस आयटा एस वाई, एंड डी एक्स की जगह हमारे पास आ जाएगा आयटा एस डी वाई. नाउ इंटीग्रल 0 to infinity, left hand side is gamma m and right hand side is this iota s raised to power m minus 1 or s raised to power 1, then s raised to power m. Iota raised to power m minus 1 or iota raised to power 1, then iota raised to power m. Then e raised to power minus iota sy and y raised to power m minus 1 and dy. Now taking s raised to power m to left side, s raised to power m, gamma m upon s raised to power m can be written as integral 0 to infinity iota raised to power m e raised to power minus iota sy y raised to power m minus 1 into dy. Now we know that iota can be written as cos pi by 2 plus iota sin pi by 2, because cos pi by 2 is 0 and sin pi by 2 is 1, so 0 plus iota into 1, that is iota. So iota can be written as cos pi by 2 plus iota sin pi by 2, and cos pi by 2 plus iota sin pi by 2 can be written as e raised to power iota pi by 2. Now substituting the value of iota, integral 0 to infinity e raised to power iota pi by 2 raised to power m e raised to power minus iota sy y raised to power m minus 1 and dy. Now left hand side is gamma m upon s raised to power m. Now taking the value of e raised to power iota pi by 2 m division, and right hand side is integral 0 to infinity e raised to power minus iota sy and y raised to power m minus 1 into dy. Now changing the variable to x. Changing the variable to x, we get right hand side e raised to power minus iota sx, and from here x raised to power m minus 1 and dx, and from left side gamma of m upon s raised to power m and e raised to power minus iota pi by 2 m. Now from left side gamma m upon s raised to power m and e raised to power minus iota pi by 2 m can be written as cos m pi by 2 plus iota sine minus iota sine m pi by 2, and right hand side can be written as integral 0 to infinity cos sx minus iota sine sx x raised to power m minus 1. Now equating real and imaginary part. Equating real and imaginary parts. Then we get from left side gamma m upon s raised to power m cos m pi by 2 is equal to integral 0 to infinity cos sx into x raised to power m minus 1 into dx, that is Fourier cosine. By the definition, Fourier cosine of fx is integral 0 to infinity x raised to power m minus 1 cos sx into dx from first equation, and it is real part, and imaginary part gamma m upon s raised to power m sine m pi by 2 is integral 0 to infinity sine sx into x raised to power m minus 1 into dx, that is Fourier sine of fx. This is the final result.